Hello friend, welcome to the another session of talent tutorial classes. Today we are going to cover part 3 of real numbers. In this session we are going to cover the fundamental theorem of arithmetic and the exercises related to it. So let's get started. So before we understand the theorem, you need to make sure that you know the meaning of what is the prime number and what is the composite number. So if any number has only two factors, 1 and itself, then it's a prime. For example, I am taking a number 3. Then the factor of two factors of 3 are 1 and 3 itself. Then it's called prime number. Next, what is composite number? If a number has more than two factors, then it is called composite number. For example, if I am taking 4, then the factors of 4 are 1, 2, 4. So it's called as composite number. So now let's read what is Fundamental Theorem of Arithmetic. Every composite number can be expressed or factorized as a product of prime, and this factorization is unique apart from the order in which prime factors occur. So in next slides we will just look at the questions. Based on those you will able to easily understand what is the meaning of the arithmetic theorem. Moving to the next. Here comes question 1. Consider the number 4n where n is a natural number. Check whether there is any value of n for which 4n ends with the digit 0. So understand the question. Let's take two examples. Let's take two number 10 and 100 which is ending with 0. What you can find here, 10 can be represented as 2 into 5, 100 can be represented as 2 into 2 into 5 into 10. So what is a special thing that you are noticing over here? That for any number which is ending with 0, the two factors will remain common, which is 2 and 5. So now let's go to this question where it's asking to find out whether we can represent 4n in terms of digit 0. So let's do one thing. 4n we can represent in 2 into 2 power n. Does not have 5 as a prime factor. So if you notice here, it just have 2, it doesn't have 5. So we can say that it does not have 5 as a prime number. So a number to be end with 0, it should have both 2 and 5 as a factors, then only it can be represented in terms of 0. Therefore, 4n cannot end with 0 for any natural number. Let's take another example. Go to the next slide. Question 2. So here in question 2, we will find out student Lcm and Hcf of two numbers by the help of prime factorization method. So look, there are two methods that I have explained in going forward in all the examples. So what you have to do, you just see which examples or which methods suits you the best, which methods you feel it's more easy for you to understand and recognize, then you take the same method for your examinations. So in this question, you have to find out Lcm and Hcf of 6 and 20. So if you see here we will find it out 6. How we can it write in terms of prime factor? 6 can be divided by 2, then 3 will remain, then it can be divided by 3 and then 1 will come here. So how you can write it out? 6, 2 into 3. Let's represent in the form of power. 2 power 1 into 3 power 1. Next, same as 20. So 20 can be represented into 2, 2, 5. 20 can be again represented in terms of power 2 into power 2 because 2 came here twice into 5. So HCF, highest common factor, product of smallest power of each common prime factor. So from both the number 6 and 20, which number is common over here? 2 power 1. If you see this side, 2 power 1. Yes, that's also come here. 3 power 1. 3 comes here? No. 5 in the other way, if you see, 5 is here, but 5 is here? No. So what is common here? 2 power 1. It is coming in both the numbers. So the highest common factor is 2 power 1 and it will become 2. Similarly, lowest common factor. Lowest common factor, so power of the product of the greatest power of each prime factor. So here 2 power 1, 3 power 1, 2 power 2, 5 power 1. So the greatest power, 2 power 1, Here also we have 2 power 2. So which is the greatest power? 2. 2 power 2. So we will take 2 power 2. Here we have 3. Here we don't have 3. But here in 3 we have power 1. So this will become the greatest. So we will take 3 power 1. Next 5. 5 is here but 5 is not here. And the common over thing is like 5 power 1. So we will take 5 over here. So the LCM will become product of the greatest power of each prime factor. 2 power 2, 3 power 1 into 5. It will become 4 into 3 into 5, which will become 60. So HCF is 2 and LCM is 60. Now let's understand the another method. Similarly, as per previous example, this is how you can denote 6 and this is how you can denote 20 in terms of factorization. Let's write it down. 6 equal to 2 into 3, 20 equal to 2 into 2 into 5. Which is common in both the cases, 2. It will become 2. HCF will become 2. So this is another way of finding it out HCF. And let's see method 2 of finding it out LCM. How you can write 6 and 20. Let's start factorizing both the number at the same time. So we can start it with 2. 2 will factorize both 6 and 20. So we have to start with the minimum number 2. So once you divide 2, 3 is 6, 2, 10 is 20. So it will become 3 and 10. Is it some number which cannot be divided? No, it can be divided again. So what you can do? 2 will divide 10. So 3 will remain as it is and 2 5 is 10. So here it became 5. Next, you can divide it by 3. 3 1 is 3 and 5 will remain as it is. Again you can divide by 5. So 5 1 is 5. So you can keep on dividing until you can find 1. So now what you will do? LCM, your LCM become complete number by which we have divided your two integers. 2 into 2 into 3 into 5, which becomes 60. So that's how, friend, there are two possible way of finding HCF and LCM of a number. And in the next example, why I have given little bit more description over here so that you can understand this particular question in more detail. And next example, we are going to cover it little quickly. So let's move to the another slide. Question 3. Find the HCF of 96 and 404 by prime factorization. Also, find the LCM. So method 1, as I said in last example, method 1, you can find it out 96 and 404. So you can keep on factorizing until you get 1. Similarly for 404, keep on factorizing until you get 1. Or the number is not getting divided anymore. So you just keep on dividing until that point of time. So 96, how you can write it over? Take everything from here, 2, 2, 2, 2, 2, 5, 2 and a 3. So 2 power 5 and a 3. And for 404, how you can write it down? 2, 2, 101. 2 to the power 2 and 101. So HCF, how you can write it down? The HCF? HCF is the smallest power of each common prime factor. So which power is the smallest? 2 to the power 4, which is over here also. So you can find it out HCF as 4. Method 2, how to find HCF? Try recollecting how we have learned in our previous slide. So what we'll do? We will do the factorization again in the similar way and we will write it like this. Instead of writing in the term of power, we will simply write it one below the other and just select the section which is common in both. So 2 into 2. So here also the highest common factor of the number is 4. So answer is both in same way. Whichever methods you like, you can take up in the same way in the examination. Also, one more thing to note it down over here. In the question, they have asked find the LCM. So what you need to do, HCF into LCM becomes a product of the number. So here we have HCF. We have product of number also, 96 into 404. So we will find it out LCM. So it's very easy. Just find it out. LCM will become, this 4 will come over here. It's very easy, right? 96 into 404 by 4. So your lowest common factors become 9696. So let's move to the next questions now. Find the HCF and LCM of 7, 6, 72 and 120. So we will apply two methods again. How we can write 6 in terms of prime factor? 2 power 1, 3 power 1. 72, 2 power 3, 3 power 2. 120, 2 power 3, 3 power 1, 5 power 1. So highest common factor you know, right? The lowest common power which is available across all the three integers. So you notice here 2 into 2 power 1 by 3 power 1. It's common in all the three integers. So HCF becomes 6. And LCM is the product of greatest power. So which is the greatest power across the three numbers? So if you see here, 2 power 3 is the greatest, 3 power 2 is the greatest, and 5 power 1 is the greatest across 3. So LCM will become 360. Method 2, again you'll write it in this format. Just write all the three numbers one below the other. 6, 2 into 3, 72, you can write in terms of factorization. 120, you can write in terms of factorization. So once you'll find it out, HCF if you see here, 2 is common across all and 3 is common over here. So HCF will become 2 into 3, which is 6. And the other way to finding out LCM is like you will take the factorization of all three numbers together, 6, 72, 120. Start dividing it by 2. Then again 2, keep on dividing until you get 1, 1, 1 at the last. So LCM will become 2, 2, 2, 3 times 2, 3, 3, 2 times 3 and 1 times 5, which is 360. Okay, so let's now move to the another slide for another question. Okay, so question 5 is almost same that we have done in the one of the previous slides. So I'm not going into the detail, but here you just need to find the HCF and LCM. So HCF you can find by the two methods, and LCM again you can find with the formula that we have already seen in the previous examples. So let's move to the another slide. Question 6. Express each number as product of its prime factor. So here we have a couple of numbers, integers. So how you can write it in the form of prime factor? 140, 156. So it's quite easy. I think it's the same way that we have learned in one of the previous slides. So let's go to another slide. Question 7. Find the LCM and HCF of the following pair of integer and verify that LCM into HCF product of the two numbers. So there are three examples. We will start with example number 1, 26 and 91. It's in the same way method. Here we have just applied the method 1. If you want to again view method 2, you can refer the slide 4. What we have already discussed previously. So part of method 1, 26 and 91 can be written in a factor as is 26 equal to 2 into 13, 91 equal to 7 into 13. So in terms of power, it's just 1 and 1. So HCF is the common for both the numbers 13, and LCM will be 2 into 13 into 7, which is 182. And the next question is like we need to verify LCM equal to HCF is equal to the product of the two number, which is the equation or the formula you can say. So right hand side and left hand side, if you can see, HCF into LCM 2366, and right hand side is the product of two number, which is 26 into 91 and 2366. So which is same for both, hence we could able to verify this. Now let's move to another slide for another example. It's the continuation of the question 7, another question 510 and 92, exactly on the same way how we have done in the previous slide. 510, how it can be written in terms of prime factorization, and 92. So the highest common factor will be 2 and the lowest common multiplication will be 2, 3, 4, 6, 0. And similarly, we have to prove HCF into LCM equal to product of numbers. And if you just look at the left hand side and the right hand side, then you can find it out. Both the answers are same, and hence you are able to verify this. Method 2, you can again look back to the slide 4 and refer over there, and you can start implementing the same question with the help of method 2. So we will move to the next slide again. Okay, so it's again the same what we have learned in the previous two slides as a part of question 7, 1 and 2. So question 3 is also same. So here we have just found out HCF and LCM of the two numbers, which is 336 and 54 with the help of method 1. And we have verified both the product multiplication HCF LCM is equal to the product of the two numbers, and we could able to verify. So let's move to the next slide for question number 8. In question number 8, we need to find it out LCM and HCF of again the two pair of integers, which is 12, 15, 21 and 17, 23, 29. So we will apply here method 3. Method 2, you can go back to the slide 4 and refer. So exactly on the same way, 12, 15, 21, we have found it out HCF 3, LCM equal to 420. And if you just go here for 17, 23 and 29, again HCF 1 and LCM equal to 11339. Let's go to the next slide. Here we have to find again LCM and HCF of the two numbers, which is 8, 9, 25. It's just a continuation of the previous slide, question number 3. So again, I think now you should be the finding out the LCM and HCF should be super quick, easy for you guys. So I'm not going to spend much time of that. We're moving to the next slide. Question 9 is again very small. So here they have already given that HCF of two number is 9 and we need to find out the LCM. So I hope that you do remember the formula HCF into LCM equal to product of the numbers. So quickly apply the formula and we can find it out. The LCM of the two number is 22338. Question number 10. So here we need to find out whether 6 raised to n can be end with the digit 0 for any natural number n. So I hope student you do remember that in the beginning of the session we have done the same questions where 6 was 4. So applying the same method, so we'll take out the two number 10 and 100, which is ending with the 0. So we can find it out 2 and 5 should be the prime factor in case we want to represent it in the form of digit 0. So here we can notice again 6 doesn't have prime. So since it doesn't have prime, a factor 5, therefore 6 to the power n cannot be end with 0 for any of the natural number n. So quickly go to the. So this is the last slide of the session. In this slide we have two questions. So question number 11, we need to explain why the set of two number. This is one set of number and this is another set of number are composite numbers. So composite number, again if we'll recollect from the previous slides, a number have a factor more than 2. So let's take the example 1. This particular set of number, if you can see here 7, 11, 13 and here 13 plus 13. How you can represent it again? 13. If you'll pull out 13, then you will remain with 7 into 11 plus 1. Again, you can write it like 13 into 7 into 11, 77 plus 1, which will become 78. 13 into 78, which can again be written as 13 into 13 into 3 into 2. So entirely the set of first number we are writing in the form of prime factors. So now you can notice that it has 13 as a factor, it has 3 as a factor, it has 2 as a factor. So it's having more than 2 factors. That is why we can say that it's a composite number. Similarly, set of another numbers. Again, we are representing in the form of 5 and then everything inside this bracket. Then 5 into 1008 plus 1 will become equal to 5 into 1009. Since it has more than 2 factors, it have 5 as a factor, it have 1009 as a factor and 1 as a factor. So we can say that it's a composite number. Okay, so now we are on the last question of this session. So here it's a reasoning question. So you just understand the question and you will be able to find out the answer very quickly. So basically what they are saying, there is a circular path around a sports field. So there is a sports field and it have a circular path. Sonia takes 18 minutes to drive one round of the field, while the other student, Ravi, he takes 12 minutes for the same path to cover. Suppose they both started at the same point and at the same time and go in the same direction. After how many minutes they will meet again at the starting point? So basically, if you understand like this, so time taken by Sonia to complete one round 18 minutes and time taken by Ravi to complete one round 12 minutes. So time taken by both to meet again. So we will find out the LCM of 18 and 12. So what we get? 36 minutes. At 36 minutes, they will both meet again. So this is what the requirement of the question. What time they will meet again? So after 36 minutes, they will meet again. And here by with the help of method 2 again, if you'll find it out, the answer will remain same. So now student, we are on the last slide of this session. So I think we have covered all the questions which I wanted to cover in this part 3 of real numbers. So that's all I had for today's session. So thank you for watching it. If you like this session, request you to like, share and subscribe. I'll get back soon with the part 4 of the real numbers, and by that we will be finishing the chapter. By that time, please take care. Have a good day. Bye.